Problem number 6. Find the effective resistance and supply current of the circuit shown in the figure 1.15. Here, three resistors are connected in parallel. The supply voltage is 12 volts. Therefore, the voltage across R1 will be 12 volts, voltage across R2 will be 12 volts, and voltage across R3 will be 12 volts. So, we need to find the equivalent resistance, that is Req. And also, we need to find the supply current. So as we know that the formula for equivalent resistance is 1 by R is equal to 1 by R1 plus 1 by R2 and 1 by R3. So as we have three parallel resistance, we are calculating for the three resistance. So this is 1 by R. So 1 by R is equal to 1 by 8 plus 1 by 6 plus 1 by 4. These are the value. This is for 1 by 8, 1 by 6 and 1 by 4. So therefore 1 by R is equal to 0.541. So therefore the total resistance, that is R, is equal to 1.85 ohms. So this is the equivalent resistance Req. Then we need to find the supply current. Supply current, we know the current, voltage and resistance relationship, that is I is equal to V by R. We know that supply voltage is 12 and we found out the equivalent resistance, that is 1.85. Calculating this, we get the current 6.49 amps. Problem number 7. A current of 10 amps is divided between two resistors in the circuit shown in the figure 1.16. Find the current in each of the two resistors. So here we need to find I1 and I2. So as this is a parallel resistance, current in each resistor will be different. Only the voltage across them will be same. So to find I1, this is the formula. So how did we get this formula? I will show you. We know that equivalent resistance, if there are two parallel resistors, right? So this is for equivalent resistance will be R1 into R2 divided by R1 plus R2. So this is the equivalent resistance. So we need to find the current I1. So we will simplify this R1. So this will be equal to V by I1. This R1 will be V by R1. So we remaining as it is, we will write that. So R2 divided by R1 plus R2. So this side R will be there. So if we bring I here and R this side, so we will get I1 is equal to V by R and R2 divided by R1 plus R2. So V by R, we know it's I. So I1 is equal to I into R2 divided by R1 plus R2. This is the formula to find current I1 if there are parallel resistors. So this is what it is written here. So we know the supply current, that is 10 amps, and we know R2, that is 2, R1 is 2 and R2 is 2. So simplifying this, we get I1, it is 5 amps. So we know the supply current. So if we subtract 5 amps from the supply current, we will get I2, that is 5 amps. So thus we see that equal resistance share the supply current equal. So as the value of the resistance are equal, so we can tell that the current shared by them will also be equal. That is what it is proving here. Problem number 8. A current of 10 amp is divided between two resistors in the circuit of figure 1.17. So find the current in each of the two resistors. So here we need to find I1 and I2. In the previous problem, we got to see that R1 and R2 were equal, that is 2 ohms and 2 ohms. Here the two resistance value are different. Here R1 is of 2 ohms and R2 is of 4 ohms. So therefore the current will not be equal. I2 and I1 will not be equal. So we need to calculate. So first we will calculate I1. So from the in the previous problem I have showed you how this formula has been derived. So using this formula we can calculate I1. We know the supply current, which is 10 amps, and resistance value of R2 is 4 ohms and resistance value of R1 is 2 ohms. So simplifying this, we get I1 is equal to 6.66 amps. So by subtracting I1 from the supply current, we get I2, that is 3.34, or you can use the formula what we have used to calculate I1. So that will be same as 3.34 amps. So from this we can say that thus it is seen that the lesser the resistance, greater its share of the supply current. So if the resistance value is less, then the current value will be more. So if the resistance value is more, current passing through that resistance will be less. Problem number 9. A coil of 12 ohms resistance is in parallel with 20 ohm resistance. This combination is connected in series with the third coil of 8 ohms resistance. The whole circuit is connected across a battery having an EMF of 30 volts and an internal resistance of 2 ohms. Calculate the terminal voltage of the battery and the power in the 12 ohm coil. So this is the circuit where 12 ohm and 20 ohm resistance are in parallel, which this combination are in series with the 8 ohm. So this 2 ohm is the internal resistance of the battery with the supply voltage of 30 volts. So this is current I. First we need to find the terminal voltage. Terminal voltage is nothing but the supply voltage minus the voltage drop of the internal resistance. So to find the voltage drop across this resistance, we need to have the value of I. To find the I, first we need to calculate the equivalent resistance of all the 4 resistance, that is 12 ohm, 20 ohm and 8 ohm and 2 ohm. So as this both are in parallel, first we need to find the equivalent resistance between the point A and point B. So the resistance of the parallel combination between A and B is RAB. So we know the formula. So 1 by RAB is equal to 1 by 12, that is the ohm of first resistance, the resistance value of the first resistor. The resistance value of second resistor is 20, therefore plus 1 by 20, which is equal to 8 by 60. Therefore the resistance between RAB is 7.5 ohms. So then all the remaining resistors are in series, so we can add 8 and 2 with 7.5. So by adding 7.5, 8 and 2, we will get the equivalent resistance, that is 7.5 ohms. So the total, now we can calculate the current. So we know the current, voltage and resistance relation, that is I is equal to V by RT, that is equivalent resistance. So we know the supply voltage is 30 and the equivalent resistance is 17.5. So therefore the supply current or the circuit current is 1.714 amps. So using this we can find the internal voltage of the battery. So we know the supply voltage, we know the internal resistance is 2 ohm. Therefore multiplying it into the circuit current, we get the internal voltage drop. So subtracting this from the supply voltage, we get 26.572 volts. So then the second point, that is the power in the 12 ohm coil. So this is the 12 ohm coil. So we need to find the power. That is, power is nothing but V into I. So power formula can be written as V into I, or power can be written as I square R, or power formula can be written as V square divided by R. So these are the three formulas. So this is the easiest one, as we know the current and we can find the voltage across the 12 ohm resistance. So first we will find the voltage across AB. That will be I into RA, that is nothing but 12.855 volts. So using this and using this formula, that is P is equal to V square by R, we can find out the power across 12 ohm resistance, that is 12.855 square divided by 12, that is 12 ohm coil. Therefore, the power will be 13.77 watts. Problem number 10. If the total power dissipated in the circuit shown is 18 watts, find the value of R and its current. So here in the circuit, we need to find the value of R and current. So that is, let us say this is I2, let us name this as I1. So we need to find the value of R and I2. So R and I2. So we know that power is 18 watts. So using this, we can find the equivalent resistance. That is, we know the power formula, that is P is equal to V square divided by R equivalent. R equivalent, as this both are in parallel and this both are in parallel, together combination they are in series. So we can find the equivalent resistance using this formula. We know that power is 18 and voltage is 12. So this will become 8 ohm, as 12 square is 144, which is divided by 18 is 8 ohms. So we got that R equivalent is 8 ohms. Using this, we can find out the value of R. So we know the equivalent formula, that is 8R divided by 8 plus R plus 4 into 16 divided by 4 plus 16. So by simplifying this, we will get the value of R, which is nothing but 12 ohms. So from this, we got R value, that is 12 ohms. So next we need to find I2. So before finding I2, we need to find the value of I. So the total current is equal to V by R equivalent, that is 12 by 8, which is nothing but 1.5. So I is equal to 1.5 amps. Now we know the current formula when the resistance are in parallel. So I2 is equal to I into R1 divided by R1 plus R2. So here I is nothing but 1.5, R1 is nothing but 8 plus, we found out R2 is nothing but 12. So using this, we will get 12 by 20, which is nothing but 0.6. So the I2 value will be 0.6 amps. So the resistance value is R and its current is 0.6 amps and the total current is 1.5 amps.